Hello, in this lecture we are going to talk about null checks and how to avoid them. The goals of this lecture is to understand the implication of methods that return nil or null. So nil is actually the equivalent of null in Java or C#, for example. We are going to analyze what happens in the side of the provider, so the one that returns nil, and what happens in the client side. And we are going to see how to avoid propagation by correctly initializing objects, and then how to also use a design pattern called Null Object to avoid nil checks. So what is nil in Pharo? In Pharo, nil is an object, as any other object in the system. It's an instance of undefined object. So every time that you write nil in the code, this is like a reference to a singleton object that points to this instance of undefined object. This is equivalent to nil in other languages such as Ruby, or null in other languages such as Java. The main difference between Pharo and Java is that in Pharo, nil is a real object, as anybody else, as any other object in the system, but it's just a singleton object. There is only one instance of undefined object. Also, similarly to other object-oriented languages, every time that we are going to create variables or instantiate objects, the variables are initialized as nil. So every time, for example, if you have a point class with an x and a y attribute, every time that you do point new, the object that is created will have an x variable and a y variable that will point to nil, to the same nil object. This also means that we need to be careful and we need to know when to use it and when to not use it. So they will come by default, but we can manage it. So let's first look at what happens from the side that returns nil. Yeah. So every time that you write a method, so m that returns nil, or a method n that will do some if condition, if true, return nil, else return 7, for example. The question is, what happens with this? What are the consequences of doing this? Yeah. So we can ask ourselves this question. Let's approach this with an example. So here, for example, you see the code of an inferencer. So it's a rule system. It's a simple rule system. We have an inferencer object that has rules to be applied in certain conditions. For example, here there is a little DSL that says, okay, when it is sunny, I'm going to use sunglasses. And when it is sunny, I am also going to use solar cream. When it is rainy, I'm going to use an umbrella. Yeah, so this little arrow is, if it is this, I'm going to do this. So here what happens is that if I take the inferencer and I ask, okay, give me the rules for sunny, it returns a set of rules. So here it's an array where the first rule is, okay, since it is sunny, I'm going to use sunglasses, and since it is sunny, I'm going to use solar cream. Now, what happens if I ask the rules for some weather that was not programmed in the set of rules? So, for example, here we can ask, okay, what happens if it is cloudy? And right now, our inferencer is returning nil. Yeah. So we can check out how this is implemented. In this case, every time that we ask the rule for a fact, so here the fact will be cloudy or sunny. Yeah, so it will be the symbols sunny and cloudy. First, we check if we have rules for that fact. If we have no rules, we return nil. Otherwise, we return the rules that apply for that fact. So nil here, it is used as a token to indicate that there were no rules for that weather, or for that fact in this case. So now, what are the consequences of returning this nil? We're going to see those consequences in every place that is calling this method, so in the clients. So returning nil in our rule method means that every time that there is a method that is going to call this method, it has to check if the result was nil or not. So every time that we are going to call this method, we are checking if it is nil or not. So that means that all the code that is doing this will be followed by conditional checks all the time. So this will somehow pollute the code and make it more difficult to change. So one solution to this is to use polymorphic objects. So if we think about this, so one way to avoid this is that to avoid the problem that we saw before is that if we ask for the rules for a weather that is not there, we could return an empty collection. So if we ask for the rules that, for a weather that we know, we are going to return the collection of rules that match. And if we ask for the rules of a weather that doesn't exist in our system, we can just return an empty collection. So, of course, an array with elements is polymorphic to an array with no elements. So that will simplify the code and allow us a simple way to manipulate the result of our method. So, of course, in this case, since we were returning collections, the choice is easy. We can just return an empty collection. But you can think of this as when you were studying math. So we can think that the collection is the zero or the neutral element of the collection. So when you concatenate the collection with another collection, it will return the same collection. Or when you iterate a collection that is empty, it will do nothing. So it is an element that does nothing. So it represents the empty or the no collection, naturally. But in cases when we are, for example, manipulating numbers, we can return 0, for example, if we are going to add them. If we are going to multiply them, maybe we want to return the 1, yeah, and so on. So this is a kind of rule that we can apply to many cases when we are adding or removing, actually, these nil checks. So that means that the code that we saw before can be refactored to look like this. So instead of returning nil, we can just return an empty collection. We return an empty array in this case. And then the client can be refactored or replaced by this code. So now we don't need a nil check anymore. We can just iterate the result of our method. So if we have rules for a fact, this is of course giving us a collection of elements that we're going to iterate and do some code here for each of the elements. However, if we don't have any rules for this fact, this is going to return an empty collection, and the iteration will just do nothing. So what are other ways of limiting the propagation of nil? So first, we should think about the methods that are returning nil and try to avoid them. So for example, adding these null elements. We can also store, or we should also store, avoid storing nil in variables explicitly. So one of the rules is to avoid explicitly using nil as a marker. And of course, to do this, we can initialize properly the instance variables of the object. So remember that every time that we are going to initialize an object, all the instance variables are going to be initialized with nil or with null in other languages. So it is the developer responsibility to produce objects that are well initialized. If we provide objects that are well initialized, we can avoid nil checks in the rest of our code. So to give you an example, here if we have an archive, we can define in Faro the initialize method. In the initialize method, we can actually take care of the initialization of all the instance variables that can have default values. So here in this case, we can initialize the members instance variable as an ordered collection. Of course, sometimes default values are not enough, and sometimes the values that should come as the values of our instance variables should come from the outside. So a good way to provide a well-constructed object is to provide a constructor method. So we can say, for example, that the only legal way to instantiate a point is by doing it using a constructor method like x7, y17. Yeah? And this will create a point that will have a correct value of x and a correct value of y, and avoiding nil in points. Of course, you may think sometimes you have to check. We don't have empty collection, so collections have empty collections. Numbers have 0 or 1 as potential null object. So what can you do when you have some object of your domain that you want to represent as empty? So one way to do it is to represent it with what we call a null object. So you can turn your default case into a null object of your model. So here we have some code taken from Faro, actually. So let's imagine that we have this tool palette. This tool palette has tools inside. Yeah, so it has a selected tool in particular. So you can think about, like, for example, if you are using Photoshop or Paint, you have a set of tools with buttons, and then one of the buttons is selected, showing that you are using this tool. So for example, we can use the pen. Okay, we have the pen and the bucket of paint and so on. But we're using the pen. Now, it may happen that we have no selected tool at all. So the program should behave properly when no tool is selected too. If we check the code, it is asking all the time, okay, if I have a selected tool, so if the selected tool is not nil, I will do something. Or in the previous action method, if I have a selected tool, if it is not nil, I will do something else. Yeah. So if we check at the model, so in an UML diagram of this, so we see that the tool palette is using a tool. So it has, actually right now it has 0 or 1 tool. And that is why it is not nil check, because it may have 0 elements in here. So this is either a tool or nil. And we see that the tools understand we can have different kind of tools. So for example, a tool for creation, a tool for adding new nodes, and then all of the tools, they are polymorphic and they understand the same messages. They understand attach or detach handles. What can we do to actually remove here the nil check? If we only restrain ourselves to basic objects like collections, numbers, or nil, of course, we are forced to check if there is a selected tool. One way to think about this, one another way, is that we can have always a tool. And it could be a tool that does nothing when it is not selected. Because what happens in this code when there is no tool? Well, actually, when there is no tool, this if not nil check will not execute the block. And it will just continue and do nothing. So we could have a tool that does exactly that. It does nothing. And we could have the same behavior. So this actually is an idea coming from a design pattern calling the Null Object that comes from the book Pattern Languages of Program Design of 1998. And the objective of this design pattern is to provide an object that is polymorphic to other objects, but has only default actions and default values. Of course, I invite you to read it and get a deeper understanding of this pattern. In our case, what we could do is to implement the absence of a tool. So we can implement as a different class, a different object that will represent the no tool. And in this case, each no tool that we can instantiate in our system will do nothing when it is asked to attach handles or to detach handles. Then we can refactor our previous code to look like this. We can initialize initially the tool palette with no tool. So by default, no tool is selected. And then all the code in our actions will just take the selected tool, whatever it is. It is not nil anymore. Now it is either a no tool or a correct tool. And we can ask it to attach or detach the handles. So the only thing that we did in our model before was to add a new kind of tool in our model. So we just exploited the polymorphism in our model. And now, instead of having 0 to 1 element tools in our palette, we just have always one tool in our tool palette. And then the tool palette doesn't need to check anymore if it is empty or not. What are the advantages of using null objects? So the main advantage is that it will simplify client code. So there will be no need to check for null objects, for nil, all the time anymore. So since the null object will have the same API as the original objects. It also clarifies what is the default behavior. So what does it mean to have nothing selected? Now we can just take a look at the new class, the no tool class that was there, no tool. And if we inspect all the methods that are there, we can see what is the behavior of our system when there's no tool that is selected. And now this tool is also reusable. We could also reuse this code to be able to deselect stuff easily. Now, of course, as every engineering decision, using null objects has benefits, but also has its disadvantages. Now, it may not be easy to actually add null objects everywhere when we need it. So sometimes it will be difficult when we have large object graphs, for example. Also, when we have a null object, we cannot just transform it into a real object later. And finally, all clients should agree on the same do-nothing behavior. So It is easier, of course, if it has the same behavior for many parts in the application. Otherwise, we will have different node tools for different parts of the application. Sometimes it's also not easy to apply this null object because the API is too large. So if we have 50 methods to implement in our node tool, maybe it is not practical to use it, and maybe it is simpler to just put that code into the client. The same case as we discussed before, maybe we need too many null objects if they don't have the same API or they don't have the same behavior. And sometimes it's not clear what does it mean to have no behavior. So what is the default behavior that the null object should implement? That is not clear in the model sometimes. So some points about the difference between the null object or nil and the null object as the design pattern. So sometimes it is possible that we initialize an object, like for example our point, or with default values. With, for example, null values. We could initialize the point in the initialize method with x equals to 0 and y equals to 0 too. That could give us a default point that can be usable in case we didn't use the constructor. Some other examples could be, for example, to use a null time zone for times. Or we could have, for example, as we talked before, null values for common objects like collections, zeros for numbers, and so on. For exceptional cases, one thing that could happen is that instead of having a default behavior or a null object, we could use exceptions. So, for example, we can replace nil by throwing an exception to avoid errors and unexpected cases. So, for example, here, if we have a stream and the stream can be in two different states, it can be readable or writable, then we want to avoid writing on the stream if it is not writable. Instead of having a default behavior that ignores the incorrect behavior, what we can do is to just throw an exception here, for example, when there is an attempt to write into the object if it is not writable. Then it is up to the client to manage the exception, but since exceptions bubble up in the call stack, so we have methods that call each other, and at some point we have an exception, the exception automatically bubbles up in the stack, and then we can manage it in the correct layer. And we don't need to manage it directly in the caller, as it was the case for the nil check. A null object is a way to use messages to manage default values and default cases in the behavior of our systems. So we could dispatch a messages instead of if checks. We can avoid null checks returning polymorphic objects, either by using objects that are already available in the system, like collections and zeros, but we can also create our own, creating null objects, implementing our own. And also remember to initialize your variables to avoid checking for nil in the client.